Good afternoon. Yep. Good afternoon, everyone. Welcome to Emerging Topic Seminar. For people who are new to the seminar series, this is a colloquium run by students in Department of Computational Medicine and Bioinformatics. And we focus on most recent trends in quantitative and computational biology. Today's topic is going to be about mobile phones and mobile apps in medicine science. And it's our pleasure to introduce our three speakers. Our first speaker, Professor Alexandre DaSilva from Department of Biological and Material Science, School of Dentistry, Professor Nancy Gilby from School of Information, and Professor Srijan Sen from Department of Psychiatry, Medical School. So we will hear their insights in pocket of medicine. So our seminar is hosted in a way that each speaker will give a 15-minute presentation. After all three talks, we have a Q&A sections or discussion sections, and then all of you can ask questions, and you can ask to individual speakers or all three of them. And we have a delightful conversation about the mobile app in medicine science. So our first speaker is Professor Alexandre DaSilva. For people who has been to NCIBI Tools and Tech Talk, you might heard of his pain track tools. And he actually is going to bring some more exciting news about the app. Professor DaSilva is an assistant professor of biology and material sciences and the director of a headache and orofacial pain effort, or HOPE lab. He's investigating the brain as a research and therapeutic target for chronic pain disorder. Today he's going to share with us his work in mobile health, and please welcome Professor Alexandre DaSilva.
Thank you very much. Hello. Well, thank you very much for the invitation. I gave a lecture 2 years ago to a small group, and I was very pleased the conversation, the questions. So I'll be happy at the very end to answer any questions. So I'm a dentist, so I'm pretty good at provoking pain, but also studying pain. And the problem with pain is that it's hard to be objective. It's hard to get very precise data. What we usually do is ask the patient from 0 to 10, give him a number. Oh, it's 7, it's 6. Oh, actually, I like your tie. Well, let me give you 5. So, and this is when you're thinking about when you're developing care, healthcare. So if you see if that's working or not, you need, a very precise information. And for my research, in fact, the way that we do that is look at the brain of patients. We look at the molecular level, patients with chronic migraine, patients with cancer pain, patients with fibromyalgia. So that's the way that we can look at changes at functional level, structural level, molecular level. But then every time that we have to ask the patient, okay, we see what's happening in your brain and which area, the intensity, but what's the intensity of the pain? So that's why we wanted to do something that is more specific and start to develop technologies for that to help us in the clinic. So, and then I put another hat. So some of the technologies that develop, some related to virtual reality, augmented reality, brain stimulation. One that really helped us was mobile technology. and because we could actually get precise objective data from the patients before we put them in the scanner. So I'm a researcher, but in some way, because of the success, the way that it was we are collecting data for our research, that became a business. And I can give you my experience. Again, I'm not a businessman, but we are developing it actually so we can reach more people. So that we create Moxitech with other members of the university and with the help of tech transfer, incredible help, tech transfer here at the University of Michigan. Just to give you an idea, the impact of pain, it affects more than 100 million people here in the United States. And for that, $500 million per year for people that cannot go to work, health care, and things like that. If the person with chronic pain goes to a hospital for care, they're more expensive, $4,000 or $7,000 more than a person without pain. And imagine, so we are giving the care to these patients, providing the care, and at the same time you're trying to invest in new therapies and things like that, brain stimulation, or even new drugs. And then after 3 months of trial, okay, let's now see if it works or not. From 0 to 10, give him a number. 6, 7, 8. So it's just to show how imprecise the field is. So we have usually, if the FDA usually ask for the VAS, Visual Analog Scale, 0 to 10. And the problem is pain, it's not one location and one number. When I ask you, many of these patients will have pain in the left shoulder, in the right shoulder, fibromyalgia, pain in several areas. Perhaps they have the migraine. So when you give you a number that it's for everything, how can you know that your therapy is sometimes a target therapy for a particular location, or perhaps only works for the migraine but not fibromyalgia? How can you track the pain? So that's why we use in our research and we develop, and that's for like 4 or 5 years, and also with Eric Maslowski, who was the director of 3D Lab and now is part of the company, working with that full-time in the company. So we developed Moxitech. So that's to give you a broad idea what as a product, not only for the research, what we are developing. So you can have a visual analysis of the pain in different areas in 3D. It's very intuitive. You can choose mild, moderate, or severe pain, or 0 to 10. And you can focus in a particular region if you want. As a dentist, of course. One example is the intraoral area that we use in a clinical trial for oral cancer pain. And for example, we have studies with migraine, chronic migraine. So it's very intuitive, and we use that in the our clinical trials. It's time-stamped, so the patients can collect the data every minute, every second, or every month. We have control for that. And not only one patient, but we can average the data for several patients. If it's 100 patients, 1,000 patients, or different languages or places, we can average that. And we add few, not many, descriptive signs and symptoms. And we can measure the pain for one region or for the entire region. And for now, we have actually 14 languages. And the way it's actually connecting real time during the clinical trial. What we say, like bring your own device, what pharma usually needs. Sorry about that. It's hard for me to, as a research, put the business side, but actually to tell you my experience that I'm sure that many here are interested to jump in. So what's GeoPain? What are the benefits, the data flow, what we had to change, what we in this past years, what we are trying to adapt to that for the market, and how that actually helped my lab mostly. Because the way that it can help the company, the startup, actually with the help of the university, it's like my experience as a researcher and a clinician too. So the full thing is that 3D painting of the area of the body. So that can be an area and a location. Because if I ask you to tell me how much is the level of your pain, you can change a little bit. Oh, that's 7, that's mild, perhaps moderate. But when I ask you, where is it? So you know exactly where your pain is. So even if in 5 minutes after, so someone asks the same question, you know that your pain is here. You can well define that. And you can track and analyze that. And it can be, again, as I say, the single and a population of patients. Usually have sometimes 24 patients or more. And now you're working with pharma to increase the number of patients to validate the analysis. And we also can do something that it's a combination of both. For example, you have severe pain, just one point. It's not the same if you have severe pain in the entire head or entire body. So we account that, and you can see how therapies are actually affecting that. And we can send this data for the local analysis, and it can be used for now Android and iOS. So in my research, what we do is that we inject radio trace in the patients during a headache attack. And we can look at the painkillers, the receptors, opioid in the scanner. And you can see how they activate. But at the same time, we are very precise where your brains release your own painkillers. Okay, so the opiates. But at the same time, now we can account where for each patient during the scanning, where they have the pain. And we can, so in this case, with chronic migraine patients, patients with more than 15 attacks per month, if you average all the patients, where the pain is and how that changes with time. But we can now correlate that with the changes in the brain. And in fact, that was a much more significant, the correlation with the GeoPain data than with the VAS from 0 to 10. The other thing that we test, it was a clinical trial with cancer patients. Cancer patients doing chemotherapy, so that induce, especially head and neck, really strong pain because it creates inflammation in the mouth, mucosites, to the point that the patient cannot feed themselves. They need a feeding tube. So what we do is we do brain stimulation in those patients to increase the release of endogenous opioids. And in fact, we can, actually those patients lost less weight than the control group. And we can check the pain in the region across the trial. That was 20 sessions of brain stimulation in those patients. So, but the clinical trial, actually in my lab, that it really we really got excited about using the app, is that we do brain stimulation, and we got patients with temporomandibular disorders. So patients with pain in both sides of the joint, mostly. So we stimulate only one side of the brain. And this side of the brain, they control the pain and the motor action, so in the contralateral side. So we did the brain stimulation, it's non-invasively, for a few sessions, 5 days. We changed the pain area, intensity, and a combination of both using tracking the pain with GeoPain. In the contralateral side, the pain decrease and the intensity and the area. No changes here in the ipsilateral side compared with the sham group. So during the clinical trial, those 5 days, we could see the changes. So it was very significant. The VAS, only 1 month after the clinical trial, that we saw changes in the treatment. So it was very sensitive for changes during the clinical trial. And so that's what we can see too. In patients, what we see in green areas that in the contralateral side that decrease the pain. But that's research, and how to make it available to the market so that we can improve trial in pharma, for example. So we are now have this available as in the app, but as an iOS and in the other way. But we can do in standalone. So we provided the app, or the app can integrate with the apps and devices from the pharma. So let's say the pharma is already dealing with another company that control the clinical trial. Oh, this is cool, but I'm not going to change everything because of you. In fact, we can integrate with the system, and the patient doesn't need to open 2 apps. It just app and work together. And we can not only visualize the data, it is actually we can throw all the entire data for them to do further analysis with that, as we are doing in our research. And then we can connect with the existing data, and we can analyze, for example, when they take the medication, how that correlates with the pain and everything. So this actually was key for us. So because when you force the market, okay, you like it, you have to use this. But the market is already using so many devices, so many different apps that we have to learn how to integrate with them if they don't want to change their own system. So that's why we offer these 2 models. One is standalone. We provide the app with the information, everything related to the pain. The other one, even if they add with the act with the pain, they analyze pain, so we can integrate with them. And they can get all the data and analyze further, and not only the visualization. So what are the things that we are offering as the original thing? One is time-stamped. It doesn't matter. When the patient is adding the data, can be every second, every minute, every hour, every month. For 3 years, we have how to analyze the data. You choose when you want to analyze. The intensity, we can average the data for a particular region or for the entire body. So if here is 3, here is 2, and here is 1, we can average that and give us the right number. And total intensity and the pains, which are a combination of both. So for the market, what they are really interested, the pharma and the hospitals, it's like, is it easy to use? Because you just give an example here, we have people different ages. But nowadays, if you do something very intuitive, for example, people with experience in gaming, who are part of our company. So you have to use something that it's appealing to keep going, and you use once 1 week, but second week you are there interested in use. And you understand, you don't need to read things right away, understand what you have to do. And reduce the trial size. So it is a small clinical trials that we had, and now we are working with pharma to use in a large scale so that we can validate the data. And the time of significance, we can see, because we can divide the pain relief in specific areas depending on the treatment too. So that's what is appealing to pharma. And the way that we are working, it's a very diverse group. And we have more people working with us, but basically I'm working as a CMO. We have Dr. Eric Maslowski, who was the director of 3D Lab at the University of Michigan. We have also from the business school with Modi, that's actually going to meetings in California and contacting pharma with us. And sometimes I contact direct, and that has been extremely helpful. So basically, this is experience. It's something that, as a researcher and a clinician, what we use in the clinic, what I use in the research, it was not really helpful, was not objective, especially when I collect data from the patient. So we developed something, and then it was successful in the way that we got the data and correlated with the brain imaging, things like that. And now we are working with with pharma and hospitals to integrate this with their system. It's a struggle. It's hard as a researcher to do something like that because it's kind of odd to show videos and things like that. But if you wanted to reach more patients, that's the way to go. I can tell you, the University of Michigan, the tech transfer, they've been extremely helpful, helping us to connect with pharma and other companies. Thank you very much.
Thank you, Dr. DaSilva. So that was great to hear that already your app is in function and has given results. If you have any burning questions, I would ask you respectfully to please hold them till the end because we will have a panel-style discussions. So we will have 15 minutes of presentation from each professor. Our second speaker is Professor Nancy Gilby. She is actually the first Ehrenberg Director of Entrepreneurship in the School of Information, where she is also an adjunct associate professor. She received, in 2007, she received the Distinguished Alumnus Award from the Department of Computer Science and Engineering. So she's from University of Michigan. She has been involved in major roles in various information technology companies, including Apollo Computer, Assurant Mobile Application Division, A2O Mobile, and several others. And also from her profile, I gathered that she has headed a lot of successful startups. So that's exciting. And another thing I noticed was you coach young adults, teenagers, and kids who are interested in competing in robotics competitions in your free time. So that's really interesting. And her industrial experience gave her a different point of view to the story. So that will add on to what we learned from Dr. DaSilva today. And we're going to hear from her recent work in mobile health and also on the entrepreneurial side of it. So please help me welcoming Professor Nancy Gilby.
Thank you very much for having me come speak today. I'm honored, and I hope I can give you some information from my perspective and then hopefully also challenge you from another perspective. So I am actually not an academic by training. I have an undergraduate and graduate degree from EECS, as we spoke about. But my love and passion is really leading bleeding edge technology. And it's not the area that I typically tell students or faculty or anybody interested in entrepreneurship to pursue, but that's just happens to be what I love. So I actually started my career working for Mitch Kapor, who actually made the first commercially successful spreadsheet at Lotus when he founded his first company. And that really got me connected in terms of the bug. So I did a lot of firsts. We developed the first online group calendaring, which is Meeting Maker, the first index desktop search, which was on location. I was spun out, then worked with a group of people who our chief technical officer was from Xerox PARC, and we developed a precursor to Java, which eventually went over to Sun and was repackaged and marketed into what it is today. The first voice-based assistant called Wildfire, which I worked with Rich Miner and other people who went on to found Android. And I worked on a technology that was really the first group collaboration and community site on the web called Firefly, which was technology that spun out of the MIT Media Lab and was eventually purchased by Microsoft. I then went on to do many other things, B2B. I've done B2B companies, business to business, business to consumer. But primarily the last 10 or 15 years of my career was mobile, and mobile at very large scale. Doing mobile selling through mobile operators or mobile carriers. And then also a company that I worked for, Lumitron, was purchased by Asurion. And they do all the mobile insurance products. And I was very intrigued, being an entrepreneur, to do a startup inside of an insurance company, which was very challenging. But for me as an entrepreneur, I really looked at it as the glass was half full, because they have over 100 million users paying a monthly recurring revenue fee, which is, you know, just a gift for somebody who wants to actually have an audience to deliver to, where we actually paired our handset insurance with our mobile technology. So we started with a team there of, I think there were 5 or 6 of us, and we grew the team to support every single phone, every single US carrier, and early deployments with Docomo and also China Mobile as well. So I have a lot of experience in developing and deploying mobile technology. And I really enjoyed that part of my career. But I was very honored to actually be invited to interview for this position as a director of entrepreneurship, because I feel much of our technology and our entrepreneurship has gone the way of the Shark Tank or the splashy presentation, and not necessarily finding something of real value. So we start to teach and we start to encourage people in the wrong direction. So I thought, well, if I'm complaining about that, I should probably think about doing something about that. So this opportunity came up, and I, you know, grabbed it with a vengeance and went at it very much like an entrepreneur. There are a lot of entrepreneurial endeavors on campus. I had actually been part of the Center for Entrepreneurship from its very first day with Thomas Zurbuchen, helping as an alumni mentor. I got to see, you know, what we were teaching and training students internally. But the thing that I really was thinking about when I put together my program was, how do we really challenge the students on campus to really leverage their time here and all the resources that we have at the University of Michigan, and really challenging them with doing something that's an open-ended type of problem is where I fell down. So, or I actually came down on what I wanted to do. So in the School of Information, I really challenge all of our students to take on a passion-led, self-directed innovation project, something open-ended, which can be kind of scary, but it's also led to people who have decided to pursue a research track as well as perhaps an applied track. What I found in doing this, however, though, is that we do a good job. We have lots of competitions, and you can do your slick pitch and, you know, get 25K. But once that's over, we sort of fall down as an ecosystem, helping students or helping students, staff, faculty to continue on. So to solve that problem, I took a page out of the rule book of the law clinic out of the law school, where they actually have an entrepreneurship clinic that offers free help desk hours every week, and they take on projects each term. And I thought, well, we need more of those. School of Information has excellence. In fact, 80% of our students do human-computer interaction, so they have a lot of UX design, user research, customer discovery type of skills. Why don't we package that up and offer help desk and take on projects each term, so that we can raise the quality of the innovations on campus and help to support the students in between these competitions. That kind of led to the next thing, which is, okay, now I have ideas, how do I get them prototyped? So I also partner with Elliot Soloway in the EECS department, and we offer a software prototyping clinic, which does something similar, helps get minimal viable prototypes or minimal viable products up and running, so that students and faculty and staff can test their ideas very quickly, and they don't get too stuck on finding a perfect developer. So that's a lot of what I've been doing, and I do a lot of different things that tend to be very student-oriented. And I've, you know, done a lot of projects and have had a lot of students do these projects. On campus, we have about 8 to 10% of our student population who actually do some kind of entrepreneurial activity, attend something. There's very few percentage that actually get to the point of following a project and building something, though, however. And we do have an undergraduate minor now, but we only have about 2% of our population in the undergraduate minor. So I'm very pleased to have gotten up to 24% of our students actually doing one of these projects. And we're getting quite a few clients that have come through the clinic now and offering quite a bit in terms of services for help desks and other things. So this kind of led to the next thing in my plan, which is in just surveying different topics and areas on campus where I saw a real interesting opportunity, especially for our students, because we have a joint master's with the School of Public Health, is this idea of experiences and data and analysis, something that's not, regulated by drugs or by device. There's a wealth of opportunities here. We just heard from Professor DaSilva, which I love what you're doing with your app. I think it's like right on the mark. But there's so many of those opportunities out there for any one of us to jump onto and get going with. And no better place than here at Michigan. Really, I've done, in my startups, I didn't do them all in one area. I started in Boston. I did several in Boston. I did several in Silicon Valley. I did one in London, one in Seattle. So I've kind of done these startups all over the world. And I can tell you, there's really no better place than right here in Ann Arbor to get your startup off the ground. Because I can send you, a block this way, and you've got an amazing health system. I can send you a block that way, and you have restaurants and other consumer-facing opportunities. So between our 19 schools and colleges, we can get you the resource. We can get you the expertise. We can get you what you need to get started. And it's just an environment that you won't see anyplace else, and you don't see in Silicon Valley, kind of contrary to popular belief in the HBO television show. It's just not like that when you're living there. It's a lot more difficult to actually get in front of the resources that you need to get something done. So with the innovation, we actually were approached by Lenovo. I'd been working with Joyce Lee, who's a pediatric endocrinologist, who tweets as Doctor as Designer, and I was very intrigued with her approach to what she calls patient-centered design. And this idea that you can get the patient involved and you can, with the patient's help, develop solutions that you never would have thought would be possible. And so we started on this. We did a Make Health Fair. We've done different types of activities, workshops, lightning talks. And then we attracted the attention of Lenovo, who said, we are the largest computer manufacturer in the world, and we are going gangbusters into this next level of mobile technology. Really like your backgrounds, really like what you're doing. I think we have some technology you should, think about, and we'd love to give you some seed money to get this lab off the ground. So what we're really focused on is this idea of helping to support those innovators on campus who want to take on a challenge and get it through to the point of prototype. Because if you are a student and you want to work with a health system, you can't just march into the lobby and start interviewing customers. That isn't going to work. If you're a student who actually has gotten something to the point of being used with patients, how are you going to monetize it? It's a little bit different. You're not necessarily just going to put it up on the App Store and get all the money you need to even if it's a nonprofit. So we're trying to help give innovators this extra leverage and working with people around campus, not just at SI or not just Joyce and myself, but FFMI and Tech Transfer and CFE and Optimize and a bunch of different groups who have subcategories of making health to help get these things off the ground. But I think the thing that I'm excited about, and I will say some of this is still leading bleeding edge, are the new technologies coming out in mobile. Just when you think that there isn't, yet another thing that's going to be cool, you find out that, wow, there is this next thing. So how many of you have actually played Pokemon Go? Okay, so some of you have done it, or you have seen it, and it was cute. Certainly got a lot of people moving. Got a lot of press with Mott Children's Hospital and Child Life. But there's something to that that I think is really cool, and I want to just show you this video of this device that's come out, and I can tell you some of the ways and things that we're thinking about using it. Let's see. Oh, it is going to play the sound. Oh, well. It's not great music, but anyway, this is the Fab 2 Pro, and it actually has some amazing camera technology, a fisheye camera lens, and a new type of sensor, which is a depth sensor. And you think, okay, so what do I need that for? So I can better place Pokemon Go on the sidewalk? No, this can actually start to do things that are useful. I mean, one of the first useful things that really got my jaw dropping was they can do wayfinding to the last mile. Now, how many people have walked through the U of M hospital and know that that's a real challenge to be able to pull off? Well, they can do it, and they actually have this is the first Google Tangle phone, so it has the technology built inside of it to be able to sense depth and other areas and perspectives. Lowe's has an application that allows you to measure and measure different areas and places, and then actually be able to place different things in your living room to see how it fits and how it looks. So the real beauty of a device like this is that it starts to open up kind of the next level of how you mix things that are augmented into a realistic equation. And I think there's going to be areas in terms of health, and especially in terms of areas, just first, what if the patient could actually measure, their area instead of just guess? That's something that this type of technology is going to be able to do, so we can get more and more precise with these types of things. And there's going to be more that comes out with these types of devices as we go along. But I think it's kind of an exciting realm that we're stepping into. So we're actually working with a few teams right now, and we'll be offering fellowships as well to help teams work over the summer on some of these ideas that may be applicable to health and technology through the Make Health by Us. That's it.
Yeah, thanks a lot.
Here we go.
I mean, if you're interested in joining the team, you can definitely contact Professor Gilby. Our next speaker is Professor Srijan Sen. Professor Sen is Associate Professor of Psychiatry and also Eisenberg Professor of Depression and Neurosciences and Research Associate Professor in Molecular and Behavioral Neuroscience Institute. He's interested in gene and environmental interactions in psychiatric diseases. And his recent work is actually involving using mobile phone to track depressions in medical school interns, and we never know when we become research subjects. So we're going to hear from what he's found using his mobile app. Please welcome Professor Srijan Sen.
Thanks. Yeah, this was really cool to hear, and I'm definitely not yet an entrepreneur, so it's really interesting to hear your experiences and learn. So we're just starting out this mobile part of our study, but hope to find some interesting work. So as you heard, my background and my clinical focus is psychiatric disorders and depression and suicide. And just as a little bit of background, we're not doing that well as a field. We're this is just from the Times, but there's a lot of stuff among the top 10 leading causes of death. As medicine is doing reasonably well, public health is doing well, you're much less likely to die of a heart attack at any given age than you were 10 years ago. You're much less likely to die of HIV or cancer or almost anything. But the one of the top 10 that's going up is suicide, and suicide seems to be maybe even 20-30% higher than it was 10-15 years ago. The major driver of suicide is major depression, and that the rate of depression seems to be steady or going up depending on the population, and the burden associated with it is growing, and soon depression will be the leading cause of disability and disability-adjusted life years, sort of overall cost and mortality of all diseases, both in the U.S. and the world. So there's a whole bunch of complex reasons why depression and psychiatric disorders are more difficult to untangle, but I think one of the major ones, similar to along the lines that Dr. DaSilva was talking about, is the like pain, all of our assessments to date are subjective. So we go on a scale of 1 to 10 or ask a bunch of questions, and it requires the patient to both understand and be able to verbalize their symptoms and then report it accurately with and stigma and bias and all that plays into it. So that plays a role, and also we only get reports of symptoms and our phenotypes at really distant cross-sectional time points, usually when they come into the psychiatrist's office or into the lab. And when they're out there living life and actually experiencing symptoms and the real burden of their disease, we don't really know what's going on. So I think mobile technology is really exciting across medicine and other fields, but I think particularly for things like pain and depression and other psychiatric conditions, it's doubly exciting because it can give us objective and real-time measures, which is really valuable. So we're applying this to a larger ongoing study that I've been leading for 7-8 years now, focusing on a population with high levels of psychiatric illness, and this is physicians and first-year doctors. So these guys are unknowing research subjects. They're working 80, 90 hours a week. Often it's the first time they're making life and death clinical decisions, so it's stressful for patients, but also stressful for them. And the sleep is inadequate and often at different times of day. So it's been written about a lot as a stressful year. We look at the interns that start over here in the hospital at Michigan, but also at 50, 60 different hospitals around the country. Each year they match into residency programs in March and are excited and sort of wide-eyed and excited to take part in research for the next 3 months, and then July 1st they start their clinical duties. So we try to get them excited, involved in the study each spring. We enroll a new cohort of about 3,000-4,000 subjects, and then follow them throughout the year. So before the year starts, about 3.5% are depressed, which is about the same as the general population. And then at any given time during this stressful intern year, about a quarter of them are depressed. About 9% have thoughts of death, 20% are anxious, and over the course of the year they cycle in and out. So at about half of the subjects meet criteria for depression at least once. So really high levels of depression and a pretty dramatic increase in depression with this stressful experience. So we've done a lot of work trying to understand what's stressful and maybe eventually try to improve the medical education system. My background is in genetics, so we're using, and the reason we've been trying to get larger sample sizes is to do genome-wide association studies and try to understand the genetics of depression under stress. This is just one example of a variant in a serotonin transporter gene, and we found this with a few different genetic variants, that whatever gene you have or allele you have at baseline doesn't really affect your level of depression, but people with the risk allele, in this case a shorter allele at this repeat site, have a significantly greater increase in depression with the stress compared to the other group. And we're doing similar work with biomarkers, with methylation and telomere length and a whole bunch of other biological entities. But for this project, we want to apply, use this model for mobile technology. It has the added advantage that we know a group of generally relatively normal and healthy individuals, rising physicians, will encounter a major stress and develop major mental health problems. So we can predict that and follow these guys as they undergo and experience the stress. So we started with a pilot about a year and a half ago. Developed an app essentially as a research app to gather data. We send them notifications through the app on average each day to get their mood score, so we get a much more sort of granular, fine-grained assessment of their mood, not just at 3-month intervals, but at daily intervals. Your phone, iPhones collect all your locations that you go to. So we gather that information, get the GPS coordinates of every location that all our subjects go to, and have them wear wearable devices the first couple years with Fitbits to gather information about their activity and their sleep. So we've finding some preliminary data. This is just the sleep data. So the blue lines are when they wake up before they start the stressful internship year, and then after, and then the yellow orange lines is when they go to sleep. And you can see that with internship starting, they used to, before internship, they wake up on average around 8 o'clock in the morning, but once the stressful year starts, they wake up about 5 a.m. So pretty dramatic shift in their sleep, and that's not made up for a shift in the time they go to bed. So there's a pretty dramatic drop in sleep with the internship year that we anecdotally knew, but we can actually quantify once we have this tracking data, and we see a pretty strong link between their mood and their sleep that they track really well together. They both go down once the stress starts, but we see a really strong relationship between sleep. Let's say your how well you slept last night, both in terms of quality and sleep length, and your mood today. There's a really strong directional relationship, but a much weaker one in the other direction. So your mood today affects how well you sleep tonight, but not that strongly. And that kind of relationship was not known well in the field. So we can try to get it at those sorts of complex bidirectional relationships better with this sort of data. We also stumble upon random things. So mood dropped pretty dramatically on November 9th. And at first I didn't know why, but then it seemed to become clear, and it dropped differently in different groups. So women and LGBT subjects in our sample got a lot more depressed on November 9th. For some reason, people in blue states got much more depressed than in red states, and then they got depressed again at inauguration and kind of stayed low. I don't have that here, but this isn't the purpose of the study, but we sort of stumble upon this and a few other different things based on our data. And another thing we've sort of noticed is that with the daily mood monitoring and wearing the wearable devices, I only did it as a way to gather this data, but we're seeing that it has an intervention effect on its own. So people, so about 100 of the residents starting here at Michigan were this part of the study, and the other 150 Michigan residents were part of our larger study, the genetic part, but not with Fitbits and daily mood. And we saw the people we were tracking closely got about half as depressed as the people we weren't tracking as closely. And then once we stopped the tracking part of the study at the end of December, those people we were tracking closely reverted back to high levels of depression. So it seemed like something about the tracking of mood and activity and sleep was having an intervention effect on its own. So we are just starting a new MIDAS grant and project to try to delve much more deeper into this and track a lot more subjects to really get the relationship between sleep and activity and heart rate variability and a whole bunch of different variables we're gathering from the mobile devices, and really see if we can predict people getting depressed before they get to the sort of depths of their the worst parts of their diseases, so we can follow that more closely, and then try to build on and unpack this intervention effect by doing these sort of micro-randomized trials and feeding back different types of data on sleep, on activity at different times of the year to the subjects, try to figure out which component is really key in helping to prevent depression, and hopefully develop some tools around that. And for this, we're partnering with a couple of different, with Verily, which is a branch of Google, to try to do some of the data analysis and machine learning, and Fitbit has some newer devices and algorithms of parsing their data, and particularly the sleep data, and so we've been working with them to try to figure out a plan to analyze this data. But hopefully in the next year or so, we'll gather some a lot of this information and get to unpacking some of these ideas. So that's where we are right now, and hopefully we'll have more soon. So thanks for listening. Keep it. Okay.
Now I would, thank you, Dr. Sen. I would invite our speakers to join us over at the desk, and we'll begin with a panel-style discussion. So any and all questions are welcome, and you can specify to whom you want them to be directed or to the group as a whole, and there's no limitations. You can be as specific as to methods or even ideologies, anything that you may want to start with. So any first takers, the floor is open.
Hello. Great discussions by everyone. I really liked it. So I have a grandmother who's 80 years old, not really, that great with technology. So I wanted to know, are companies also taking into account, elderly clients and their ability to use your products?
Our first patient that we are actually always trying the app when we use only in our lab was the grandmother of Eric Maslowski. So she was actually using, she was in her 80s. So we want really to be intuitive and just press the button and the color and mark where the pain was. And that has actually helped us to do something simple, because it's very easy to a researcher to make it very complex. Oh, I can get data here and there, and I think that more and more we are connected with technology, even if you are older, and so it's become more and more available. I can see my in-laws at home. Gosh, they use much more my cell phone and the computers than what I usually do. And they want to get the news. They wanted to be connected with the daily things. It helps them socially too.
Yeah, I would say that depending on the particular app that I'm in, app or technology I'm involved with, I've seen a lot of sensitivity towards making sure that elderly or almost elderly are able to use the technology. Everything from making sure that the text size is readable to simplistic, easy to understand user interfaces. And I was just going to mention there's also a company that we're working with in Design Clinic this term called Nova Technologies, which is from Ann Arbor Spark, and they're actually doing a telemedicine. I would call it, it's a tablet, but then an app for a tablet to be used with telemedicine specifically for elderly patients, and they're testing it with elderly patients as well. So I think it can, I think the receptivity, especially if it's valuable to the elderly, if it's just technology for technology's sake, then I think you're going to have a harder time. But if it's going to be valuable, like to an elderly person who doesn't have to get a ride to the hospital and get picked up and everything else, and not and be able to have an in-home conversation with their physician, we can build those types of user interfaces, but carefully.
What might be on your bioinformatics wish list in terms of better methods to get value out of the time series of streaming data that comes from so many of these devices and from functional brain?
I think the way that we are collecting data now, it's so much information. I mean, from the brain and from the apps. So that's why the idea, and it's appealing to me not as a market and financially, but also as a researcher, as he is doing actually is amazing research, is that we can now look at data that was not available before, so that we can make the correlations that are needed. And the more we learn, the better we can understand what we're getting. So bioinformatics is important for that, because we are extracting data that we didn't have before.
Yeah, just along the same lines. I think we're getting so much new data and data that we don't know what to do with in both type and volume. So I think figuring out new methods to analyze it, and then particularly sort of sifting through all the data that we collect and separating the signals from the noise, I think is a big problem, and we need great tools to do that and partners for doing that work. So I think yeah, the type of data that we're collecting is sort of unprecedented and different from what I learned from in grad school, and is really exciting but a little scary too.
Do you think that you have to change the IRB around a little bit to make use of this data? I mean, are there amendments to the IRB or notices that you have to give to the participants in the study or something like that?
Yeah, but I've been pleasantly surprised by how receptive the IRB, the Michigan IRBs have been to this sort of work and open to the new types of data that are available. So certainly we have to work with them, but I've been happy with that, and also with the students we've been assessing, and the residents we're assessing how open they are to sharing their data. I would be uncomfortable with people knowing my location at all times a day and things like that. Yeah. Yeah. So we're
We have this
right.
with the transportation. So we have the starting point and the end point of the trip. And we
Right.
roll all those out.
Yeah.
They're going places maybe they shouldn't. I mean,
Yeah.
you're tracing all these participants.
Right. Right.
And so that it gets down to more serious privacy.
Definitely, and we have our own protections with that, but with our information, then partnering with the information that Google collects and Fitbit collects, and we know a lot about these subjects as they go along. So we work with IRB to make sure we protect it, but yeah, there are new challenges there as well.
Just one more about students and other people in the lab, and are there special things you have to do to get them to be able to work with this PHI?
For our study specifically, we de-identify all the data before it gets to any students or postdocs or even me. So there isn't, and we keep different types of data apart unless there's specific reasons or hypotheses for putting them together. So yeah, we try to protect it.
All right, so I'm going to ask one more. So you find somebody who has a PhD of 20.
Right.
I mean, you've got to commit suicide. Then what do you do?
Nothing. We can't predict suicide well enough to do that, and the compromises we've come up with the IRBs is that we won't and can't really intervene on an individual basis. We do give everyone, and especially if they reach those sorts of levels, information about psychiatrists or therapists or even online resources that they can utilize to help themselves, but they wouldn't respond honestly to the surveys if they knew there was a possibility of intervention. So that's sort of the compromise that we worked out with the IRB. But it's not comfortable to see that data come back and not be able to do anything. But that's the best compromise we've come up with. So, yeah. But we see a lot. I mean, with 10%, yeah, with at least in my sample, with 10% of them suicide or having thoughts of death at any given time, it's a lot of that out there, and it's hard to know what to do with it.
Great presentations and really cool technology. So basically, said it. It's sort of an enormous amount of data, more than anybody knows what to do with. I mean, I would like to believe that the methods will be developed to deal with the data, but I think it's sort of, usually it's useful to think about what data you're collecting up front, so it could be used later. In particular, what I'm wondering about, is there any information on or any data to sort of the use of mobile technology, which is clearly very cool. How does it affect how accurate the data is? Because, for example, take pain, for example, it strikes me that you're collecting a lot more detailed data, of course, right? Just because people are using sort of, their mobile devices or whatever, I mean, are they assessing it more objectively, or is it still imprecise? Or, in other cases, is there any research that shows how use of mobile technology affects the, this type of data?
Well, I think that's a great point. And the only way that we can learn is actually the more data we have. It's a kind of odd thing, but when I start to do like clinical research in pain, you'd have like this paper that you put where the pain is at 7 o'clock, you put in your pocket, and you have to bring that 1 month later to the doctor. It was kind of a mess. The patient would do this. Oh, I had pain here. The migraine attack was here. The fibromyalgia was there. So that was impossible. So now we have a much more of the time points, many time points that we can analyze and see really when it is really it's data that is reliable. But I can tell one thing, and actually connects with the first one of the first questions, is that the more data we have, the more we can predict something to happen in different disorders. The good example was with his data, and the same with migraine, for example, one of the disorder that we study. I'm a reviewer for VA, Department of Defense, National Institute of Health for grants. And especially VA, sometimes this data is important, but the more important is that patients, when to intervene, which connects with the other question that we have, that if the data shows that this patient may have a worse prognosis than the other one, so we need a more aggressive treatment here, or it's time to intervene in those patients. So the more data we have, more time points we have. So I know it's getting harder, so that's why we need better analysis, better bioinformatic models, so the better we can provide treatment for the patients, even predict who we're going to need the better treatment and when to be aggressive about it. Pain, depression, other disorders.
Hello? Okay. So follow-up question is very similar. So, with this, you're collecting data to, from the self-assessments for the patients to try to predict if they're going to have complications later. And so you're more or less making the judgments based on where they select the pain and the value they assess. But probably, like you mentioned earlier, there's no normalization against the cohorts. Like someone says, I have a shoulder pain, it's 3, and someone has the exact same experience, but they selected as a 5 or a 6. So have you come up with any ideas of how you would kind of normalize it against different people who may experience the same thing but evaluate their pain differently?
That's why I love the brain. I mean, and so it's we try to validate as a research the data that we collect in the clinic. In fact, one of the last study that we have, we look at the brain in the clinical environment. The patient in the dental chair, we collect data from the brain. So there's a dentist there, the patient gets the anxiety, we apply the cold stimulus, we have the cold pain, and we continuously track the patient. And even what happened after reconnectivity, so how the brain connects. The interesting thing, the brain is very predictable. From the time that you're like, I'm about to get pain, and it's getting, this is cold, oh, this is pain, and then you have to give the rating, how was the pain? This chain of the events, one step to the other, the emotional and the sensory part of the brain, actually is very predictive. They correlate at a high level. But then when you give the number, the correlation decreases. Because it's a personal experience. However, when you start to add objective data, that's why area of the pain integrated with that's another thing. And the way that you describe the pain, okay, here is 5, but here is 6. So you start to give more tools to the patient to, to be more like true to his or her experience. And then, so the things that we are doing is correlate that with the way that we release of endogenous opioids. And in fact, we are getting better correlation with the biomarkers in the brain than the peer 0 to 10. So I think that we are learning with that. In the research lab is working, and we are now, trying a large group with a farm, and they for now they're getting interested in that. However, it's a market that's very conservative too, because it's dictated by FDA. So we needed to play change the minds step by step with research and the regulatory process.
I guess my question is for Dr. Sen. I'm just curious, like, would you expect like similar correlations or like a similar model among people in like a different profession, or like completely unrelated to like medical interns? I mean, would you expect like similar, mood and sleep, like the correlation between them? Would you expect something similar?
Generally, I mean, they're still humans. The doctors, and I think we've, we need to validate it. So, in terms of our background with the genes, a lot of the same variants that we find predict getting depressed under, not all, but some that we find that predict getting depressed under internship and medical stress, also predict getting stressed in or struggling for Army Rangers before they go off to war and training, and a couple of the other ones in pregnant women predicting who's going to get depressed postpartum. And I think we'll find similar stuff with the other, that some of the factors we find will be specific to doctors, but I think more of them will be, and especially universal things like sleep and activity, which there's no reason to think would be specific to the doctor population, will hopefully likely generalize. But anything we find here, we have to test in a general population. I think that's one of the things we've started to at least plan to do with these companies, and like the wearable companies like Fitbit and other phone-based companies that have access to the general population data on a large scale, that if we find patterns in our data, then hopefully we can pretty easily look at that in other populations and see if we see the same thing.
My question is for Srijan as well. Do you have a hypothesis for why monitoring actually helps the rates of depression going down? And related to the previous question, do you think that could apply to other complex traits, not just diseases, but also health-related phenotypes?
Yeah, I was surprised, but when we did little debriefing with the subjects, and they talked about having to put a number to their mood every day, made them sort of think about it and be mindful, and that was helpful. And that, especially in groups like doctors where there's a lot of stigma against mental health issues, that being able to put a number on it or verbalize it, they were able to communicate with each other. So they would say that, every time I had to go work in cardiology clinic, it was a 3-day for me, and that made sense to the next person, whereas before, talking about how they got sad and depressed wasn't as easy to do. And so that was part of it. And then another, it's a population very driven by feedback and getting positive reinforcements and tests and things like that. And so a lot of them said that even if I had a really bad day and a patient died, or my attending physician was yelling at me once I got the little buzz that I got 10,000 steps, at least something went right and I was doing something good that day, and that positive feedback was there. So there's, I think there's also a lot of data from other trials that just closely monitoring, feel like someone is watching or cares about you, has a therapeutic effect. So I think those are all possible, and hopefully we can try to disentangle those things. But I'm open to other ideas if you have, or other people have.
You're still with the pain, and and I might miss some of it later. You also trying to help offer some solutions to the opioid crisis.
So the app is actually part of two studies from the National Institute of Health, where we look at the brain activation of patients, the opioid activation patients of those two disorders. So my intentions later on is to use specific for opioid abuse. It's a huge problem in our state. I submit one, yes, but it's here is getting really a high level. And it's a crime. It is a crime because it's sometimes initiated by us, healthcare providers, and we do have other ways to deal with chronic pain.
As far as that side, is there a way that other units like bioinformatics here could be working with you? You know, you have some. I heard about some undergraduate activities. You have some graduate activities that we could, our students could take advantage of?
Both, actually, yeah, undergraduate and graduate. So we are, I think some of the best innovation projects are a combination of cross-discipline, cross-age, cross-background, cross everything, diversity, because to really innovate in something, you have to really look at, a very large picture. So we also too, there may be ideas that people want to pursue. I would say if you have an idea, come talk to one of us, come talk to me, and we can help you through the UX Design Clinic or potentially through the Software Prototyping Clinic or both to get your idea up and off the ground. And usually as they start to get off the ground, there's other people who want to join and see if you can do something to impact a particular area.
Yeah, good, thanks. Good. Check it out, guys.
Yeah.
Got one more, I think.
Hi, I have a question for Dr. Gilby. So I'm wondering what it takes to really launch an app. Because I used to work for an insurance company. I know it's really easy for them because they have a whole team for it. But then as an individual, especially for a student, is there any platform we can use to if we have this idea, I really want to get some information about making this app, and then is there any platform we can refer to?
Yeah, absolutely. And that's part of what I am trying to do with both of the UX Design Clinic and Software Prototyping Clinic. Speak to somebody just like you who likely has some technical background, but there's so many tools and so many choices, and what do I do to get started? And if I want to collect data, then do I really need a back-end developer and a front-end developer? And I would say no, we actually we have templates that are actually what you call full stack, so they're front end and back end. And they also have Google Analytics integrated in. So I feel like they're approachable to get a minimal viable prototype up and running and tested. And that's really your first step, number one. You have to make sure that your idea works, that you get the data that you need to report on, that it's of value. And once you do that, then there's kind of the next level of resource to really robustify your app and get it on the App Store. So, but the first part is just getting started. And I feel like we have a means of helping you and demystifying the process. So almost anybody who would like to get something up and running, we can help you.
Fantastic. With that, I think it's time to wrap up this panel session. I think we had a great mix of speakers with different backgrounds. We learned a lot from different aspects, like just from the research perspective, and then getting the idea how we can take this up to market. And I think let's thank our speakers. Yeah. And I thank you all for coming here today, and at least I personally got to learn a great deal. And we hope that we can have more of these interactive sessions from next semester onwards. Yeah, thank you very much for coming.